Hi, and welcome to this first episode of Recent Acquisitions. The content of this video used to be included in other videos under the heading Quick Tool Review, but I'm going to leave that video heading just for reviewing items that are sent to me for evaluation that I sort of select. This recent acquisition video series is going to be on tools that I find and purchase on eBay, either in lots or at yard sales or estate sales. Basically good finds that are not necessarily exactly what you're looking for. Sometimes you just happen onto things that might be useful down the line, and not everyone's in the position to just buy something you might need someday. You got to restrict the things you need now. But I'm fortunate enough to be able to do that, and so I thought I'd share the stuff I find with you. So here's an example. I bought a lot of drill bits on eBay, and I always keep my eye open for lots because a lot of times things are heavily discounted relative to the norm. So all these drill bits, they're all solid carbide. So these Goering, these are 12 millimeter. Now I don't use metric a whole lot, but 12 millimeter is just under ½ an inch. And this is a solid carbide gun style drill bit, as you can see there, with coolant through. Not that I can use that at this point in time, although I'm thinking about adding coolant through on my lathe. First, then I got to populate coolant on my lathe, but I haven't done that either because I'm really worried about corrosion. But in any case, getting off track. This drill bit came with a set of 5, among other things, so it's more than I needed. But this drill bit alone probably would be $100 if you bought it by itself, maybe more. I don't know. I've never looked. I got all of these for like $40. So even though I don't need them all, and I didn't need any of these specific sizes, sometimes they come in really handy. So for example, the gun drills are really good for drilling deep holes, but they're also good for the carbide's good for drilling in harder materials. So let's say I had some really hard material, I need to drill a hole in it, and it's going to finally be ½ an inch. I could go in with this 12 millimeter drill with the carbide and remove most of the material, and then maybe even get away with a high-speed steel drill bit, finishing the hole off to ½ an inch. Sometimes that's really handy. Here's a smaller one. This claims it's 12 millimeter. Yeah, this is also a solid carbide drill bit. This came in a pair as well. Oh no, this is 13 millimeter. Okay, 13 millimeter solid carbide drill bit. Also, it's a known German brand, Goering. This is 3 millimeter, 2 millimeter, 2 millimeter. These are really long drill bits. These are not carbide. These are high-speed steel, but got some serious depth capabilities there. Which, again, if you need to go buy one of these, you're going to pay more than I paid for the whole lot. What is this? This is 7.3 millimeter. Again, don't be afraid to get these fractional sizes. This is solid carbide. Sometimes they're really handy to pre-drill a hole or even do the final drill of the hole in a size you need. Here's another gun drill, reduced size. This is a couple millimeter, 3.3. Similar thing. So, again, $40, all these drill bits, none of the sizes I particularly needed, but someday they could be really handy. Again, if you're lucky and fortunate enough to be able to spend money that way, I highly recommend it. If not, I completely understand. Sometimes you win, and then sometimes you lose. Like this one, this wasn't purchased as a lot. This was a Kennametal holder, and I didn't look up the number because the eBay auction was expiring quickly, and I use these inserts, except I use the next size down. These are CNMG kind of thing, but this, I use 4. This is 5 or 6, and the holder is over 1 inch. It's 1.25 inches, and my lathe, I can use tools up to inch across, inch thick. So I can't even use this tool. Now I could machine this down to 1 inch thick. I've done that before. That's not a problem. But I also don't use CNMG's number 5s or number 6s, whatever this ends up being, pretty much ever. My lathe really isn't sized for that. This would be a much bigger lathe. So sometimes you lose, especially when you're in a hurry. I find a lot of times when I'm in an auction, I read something really quickly, as the auction's expiring, and just throw a bid in and then realize all too late that you blew it. Next up is another really heavy-duty indicator stand. This beauty right here. Needs some tender love and care. It's a Bendix, the Allied Bendix. I didn't even know they made indicator stands. I think the bottom base could use some grinding or cleaning up. It looks like that's parallel to this side. I could surface grind the top and then surface grind the base to be perpendicular to that. Although what I need it to be is actually perpendicular to this post here. So I should check that out. But it's got, what caught my attention, this was a pretty reasonable price, and the clamping arrangement on it was extremely heavy duty, and that caught my attention and got my interest. So I picked it up. I did not need another indicator stand, but this was so heavy duty, it really seemed pretty interesting to me. I think in order to go up and down, you've got to loosen these guys here. It's an interesting design. So this purely is the rotation of this bit here, and that is very rigid. Although there is a little, oh, that's a little play between the shaft and this vertical support here. I think this thing needs taking apart, because the mechanism, which is kind of unusual, seems to be frozen up, and I see corrosion around the edges here. So I'm kind of curious how it works. We're going to take it apart and check it out. There's also some rust in here, I notice. Spring, washer. Okay, so it's not any of that. Interesting. Oops, did not mean to drop that on there. Yeah, that dinged it. This thing was totally rusted in place. As I recall, I got a pretty good deal on this guy as well. You can see inside there's some sort of rocking mechanism that locks this. Oh, it looks like a washer may pull. I cannot tell, but everything is rusted solid. This might need some time and some evaporust. So inside one of these was a spring-loaded pawl that provided friction here, and the set screw set the tension. But there are two of them, but the other one doesn't seem to have anything in there. I'm not quite sure what the other one's job is. There we go. Now I'm getting some rotation finally. Okay. I just put a screwdriver in there. There we go. Hey, we got it. So I think this guy rides. Oh, that looks sheared, doesn't it? You see the shininess? I think that got sheared off. Oh, that's why it's not working, because this bit needed to ride on both sides. A pin coming out of both sides, so this won't work. So I'd have to make a new one of these. This is probably hardened too. So it looks like we need to make this part, which is kind of complicated. It's sloped, it's hardened, it's got a bunch of different relief sections, and I'm missing one side, although I'm going to assume it's symmetrical. That may not be reasonable, but we're gonna. So we're going to try and remake this part. But in order to do that, I also have to bore the base, so I might as well look at the next acquisition first. That acquisition is similar to what Max Grant got down in Australia, except his was in a nice wooden case. This one's in a plastic case. He was making fun of this, as a matter of fact, because it's in a plastic case. This is a Volhopter complete rip-off clone with all the accessories. And one of the advantages of this style of head is you hold the top, you put it in a special mode to face, and you hold the top, and the boring head will work its way out automatically with each revolution, which is really handy, which is exactly what I need for the base. Because what I did was I bored out the base. Let me bring that back. I ground the base of that stand, but I lost the recess portion here. And of course, it wouldn't be just some normal sized rod. It's 0.855, so you know they don't want to play well with others. Ground the base, nice flat and perpendicular. So I need to bore this. to match, just to be recessed. It doesn't technically have to be, but it sure would look better than sitting proud like this up here. I don't think that would look anywhere near as good. So we are going to bore this out, and that's where this Volhopter clone really comes in. So this kit comes with everything the Volhopter kit comes with. It has holders for high-speed steel, which it comes with a blank that you can grind, just one of them, long and small, or shorter, long and shorter, however you want to look at it. And it's got the extension shaft that can come out the side for even longer bits, for even larger diameters. It has 2 sleeves for different size boring inserts. It's a very nice kit, but it is not inexpensive. It also comes with 4 boring bars, 3 small and 1 larger boring bars. So this kit was still $1,500, but when you compare it to a Volhopter, which this kit in a Volhopter costs about $7,000. Totally out of my reach. This was really expensive. I did a bunch of jobs for my business that you've been seeing videos from, and saved all that money and bought this. So here we go. And I'm going to need to use this, so might as well get ready to set this up, because I want to do a relief for this guy, and it's 0.855 diameter. Hopefully I'll be able to figure it out, because I've never used this before. So we'll check out the instructions. That's one nice thing, is it does have instructions. And the Taiwanese, this being a Taiwanese tool, have done a pretty decent job at making readable manuals. So let's hope this one's the same. So with this boring head in normal mode, boy, this is beautiful. They did a wonderful job grinding this. In normal mode, you loosen, that part I'm actually, you know what, I'm not even sure regular boring mode, because I don't see the set screws. These are for the gib. This is, oh, you know what, this is the lock here. So when you tighten this guy, this no longer, you can no longer adjust this easily. So here we go. That's going off to this side here. Okay, that works well. And then when you tighten this guy, this is also tight. So this is your lock for your boring head right here. This guy is the lock, and there is a stop built in. Boy, that's really smooth. They did a really nice job on this guy. It's easier than I thought. Okay, I don't know if you can see this here. See the 0, the 2, the 4, and the 6? It looks like it's 0.02, 0.04, and 0.06 millimeters of revolution. Right now it's on 0, which means this is not in self-feeding mode at all. Slide it here, it's 20 millionths of an inch per revolution, 0.02 millimeters, 20 microns, 40 microns, 60 microns. And there is off. And that's a lock mode, so rotating this won't move this at all. Well, I guess we're just going to take this over and give it a shot, because that's where we're at, right? First up, I'm going to remove a majority of the material with a 3/4 inch end mill, just so that I don't have to bore all of that out. There's no reason to. Went for 1/10 of an inch deep. Next, we're going to bore it to 0.855. So here's the Volhopter head loaded, and initially I think what we're going to do is we're going to use this a regular boring head, and we're going to bore this hole to size, and then at the last step we're going to face the entire bottom using its feature where it can automatically feed it out. So when I put this, so all of the boring bars that came with this have flats on them so that they orient automatically correctly. But when you use a sleeve, like I did for the smaller bar, then that flat won't work anymore. So I had to make sure the back relief is good on this cutter. And I did that by plunging into the cut already and just making sure that when the cutting edge makes contact, there's plenty of back relief so it won't rub, because I've had that problem before. The fact that you only need 1 Allen wrench to set the depth is really nice, because the lock is a thumb screw. That's a really nice addition that I haven't seen on other boring heads. Normally you need an Allen wrench, one size Allen wrench for this, another size Allen wrench for the dial. These are 0.01 millimeter per division, which means each division is about 4/10. Since the readout is in metric, I've just got a dial indicator here, and that will let me dial in my cut. So I think I'm interested in 10 thousandths radially, which 10 thousandths radially will translate to 20 thousandths in diameter. I made the cardinal mistake of forgetting that I'm dialing in radius, so I've got to multiply by 2. So I went in 9 thousandths to get 9 thousandths, and instead I got 18 thousandths, actually a few tenths under. But we'll fix that next time, won't we? All right, so we've engaged, we've loosened this. We've put this on 60 microns per revolution, which is the fastest. We've got the boring head, the cutter all the way down in the middle, and we're going to try and face the bottom part of this off. Looks like it's going. So I got to see where I'm at. So you can set stops on this. That's what these two stops are on this side. But I don't know if those are going to help me. Okay, there we go. And we're good. That faced the bottom nicely. Okay, that wasn't hard at all. Yeah, so these two stops here, I could have set them so that it would automatically stop when you get there. So now to get the head back vertical, I can run it in reverse and hold this. Just keep an eye over here at the amount that it's offset. Get it roughly at 0. There we are. All right, so that worked out really well. We faced the bottom. I did open this hole up a couple more thousandths just to make it easy to put the bar in and out. It's only for appearance. It doesn't really hold. It's only 100 thousandths deep, so it's not very deep. They relieved a bunch of material on the bottom, which I wouldn't have done. I would have gone the other way and had the bar go down, but for whatever reason, they didn't choose to. So I think that's where we're going to leave it. This Vertex head did really nice job. I am very pleased with it. In the hole now it lies flat. Before it was rocking really badly side to side. Now it's fairly flat. I'm not sure this is perfectly flat, although it does look like they did machine a flat on it. But, oh, yeah, it looks like there's some gunk on it. That when you stop it, it does settle down very nicely, dead vertical. We've got a reference surface here. We've got reference surface on the feet. So now we just need to repair the locking mechanism, or we could always make our own locking mechanism. That one may be too far gone, but we're gonna see what we can do. Trying to remake the part that provides the positioning. I'm actually not sure that it's even the design I want. So I have some A2 tool steel here. Here's the part we're trying to make. Bad representation. Part of it's broken, so I'm guessing that it's symmetrical, but it may not be, in which case I'm kind of hosed. You can see the marks on the return. See the marks the cutter left when I brought it back? Let me just take a skim pass. Okay, you see going in, it's good. When I bring it back, there's no marks. If there's deflection, it'll cut on the way back, so as it's cutting in this way, the part's deflecting back this way a little bit. Then on the return trip, when there's nowhere near as much force, the cutter re-engages the part as it springs back. There's our relief. Now we need to cut off the stuff on the other side. That's going to be interesting. I need some left cutting tools to get in there. I'm going to work on the other side. Put a fresh parting blade in there. I'm going to take it into the larger diameter first. Okay. So there's the part. Surface finish much better on that side than the parting tool was on that side. That's too bad, but we've got to grind this anyway, so that'll be okay. Okay, air hardened steel. Go take it over the fan. Didn't oxidize too badly at all. A little bit of flaking, but I've got to grind that anyways. So hopefully it'll be okay. So I tested. You can see on the end there, it's Rockwell 42. So I didn't go full hard with it. I thought it cooled off a little slower than it should have. I should have used compressed air instead. I just used a fan. It's kind of pretty though. There's some mill scale built up on it, but I got to grind both these faces 5 degrees. The grind of 5 degrees until the thickness is 0.095. Here's the setup to grind those profiles. So I've got a rotary holder here with a 5C collet. The disc is in the side there, and I won't be able to show you this because I'm going to have a hard time seeing what I'm doing. So what I'm going to do is I'm going to touch off on the outside edge, and I'm going to go in a total of 12 thousandths, and we have it set up on a magnetic sine plate here, set at 5 degrees, and we're just going to grind that profile. We should be good. I was so proud of myself for doing such a good job. Here's the original part. Here's the new part, ground wonderfully, except I forgot one thing. I turned everything except forgot to turn down this diameter. So now it's pretty damn hard, and the whole ground section here is oh, wonderful. So I actually have to take this down to 0.8. I forget. It's left at 1.013, which was the rough stock, and it needs to be 0.812. So back to the grinder here. I thought I was frickin' done. So nothing's worth doing if you can't do it twice, I always say. So I almost had this part completely done right, and I screwed it up the last minute because I forgot to reduce the diameter. And then, like an idiot, I forgot that when you're plunging in with your surface grinder, you're plunging in radially. So you're decreasing the diameter by double, and so I decreased the diameter way too much. Here's the original part. So that one's a piece of scrap. I made another one because it's fun, and this one I did a little better job because I ground the shafts. I left them a little oversized, and I got the right dimensions. Now the question is, will this mechanism even work? I don't know. I removed the rust out of here, but I don't know if that'll be enough in and of itself. So let's just give it a shot. I was looking at the design of this, and I'm not quite sure if this should have lubricant or not. It was dry when I got it, but I'm thinking about just adding a very tiny little film. Maybe that'll be a mistake and I'll have to clean it out, but I'm going to try it. So this bit goes in here, and then this bit goes on top of that. And there's a spring holding this in, which is fed from the top. So this bit gets dropped down through the hole. And then this bit. And then one of these. I'm not sure what the second one's for. It was not apparent obvious to me from the get-go. So you can see that the that little piece is pushing on the shaft, which is pushing it into the column here. And so that'll tighten, that'll lock the column off. I'm not sure why they had this elaborate method, but let's just loosen this guy a little bit here, or a whole lot of bit there. I'm just going to put this one in. This one's just a column stop, I think. It presses against the side of this rotating bit here. I'm not 100% in how this mechanism's supposed to work, but let's see if all the effort paid off. So, oh, by the way, I ground this, and I ground the feet to match, and then bored the hole to match that, so they should all be collinear, or this should be perpendicular in any case. Let's see. It's about as loose as it can possibly get. All right. So there is a key here. That's does move up and down now. Boy, when it grabs, it really grabs. So this bit here presses into this keyway here, and since it's at a 5-degree angle, 10 total, 5 each side, it wedges. I'm not sure why the design, to be honest. It seems like a elaborate bit of work for not better than a standard cinch, but I'm not sure here. And I don't exactly know how to get it to release nicely. So let's see. This guy's loose. Oh. Column got dinged here, so that's the problem right there. It's catching. It's very smooth here. So let's see what happens if I tighten this down. This is like setting friction. Yeah. Yeah. So that just made it a little tighter. Half turn. So it sets friction on the column, and then I suppose you can lock the column with this? I don't know. No, that just locks this in place. You can certainly lock the column if you crank this thing enough. I don't know. I don't think I'm a fan of this mechanism. Well, I've got an indicator stand. If anyone's seen a mechanism like this, please reach out and let me know. This was an interesting project to work on. I think I made it better. I certainly fixed this piece here, but I don't know that it solved the problem entirely. It's a really weird mechanism. But anyone who's got an insight, let me know. Thanks for watching. Hope you find it useful. Hope to see you next time.